Go.
Hi, this is our 301 project. We are Team B6, and this is our briquetting machine. So my name is Olivia, and I'm going to be talking about the PID and heater control of the system. So we're just using a mechanical relay to moderate the high and low current parts of the system. We're using an Arduino to create the control and a thermistor to measure the temperature to control the heater output.
Okay, I'm Aiden, and I'm going to walk you through some of the electronics. So this is kind of a mixed 12 volt, 5 volt system. We have a 12 volt power supply that's rated at around 40 amps. And then that powers our motor directly, which is also a 12 volt motor. This motor, just like I said, 12 volt DC. It has a 188 to 1 planetary gearbox. So it's like maximum torque output at the shaft is around 40 foot-pounds. We know and we've experienced that the gearbox can't handle that much, and the output shaft also can't handle that much, but if you demand it, it will try to give it to you. And then our 12 volt power supply goes into our Arduino voltage input, and then that regulates it down to 5 volts for us. So we have a little 5 volt rail right here, and that's going to power our relay. The 12 volts also goes through the relay to power the heaters, which are around 5 amps each, I believe. So we're still, with the 20 amp motor, we're still around our current limit.
Hi, I'm Lucas, and so for our briquetting machine, we decided to go with a piston flywheel cylinder system. So we used a drive shaft, we used a thick rod to support the drive shaft, and we used 2 bearings to stabilize it. And then we hooked it up to a 2-inch diameter flywheel, and we used a 1-inch, half-inch radius for the actual flywheel, just to reduce stress. And then we used a 1/2-inch inside diameter pipe that's about 6 inches in length to produce the briquettes.
Hello, I'm Max. I'll be walking you through the material feed subsystem. Here we have our material feed chamber, and underneath you can see we cut out a slot in the pipe for the material to go in and be pushed by the piston. Here's the material we used. It's a combination of cassava powder, which is a good binder, and then sawdust, obviously, our raw biomass, and then also paper to help hold the briquettes together.
I'm Carter, and I'm going to talk about some of the limitations of our design. So during operation, we realized that the feed would experience a lot of friction and not enough compression in our pipe. So in order to increase the amount of forces on the feed to push the feed through and not get stuck halfway through the pipe, we not only cut down the pipe in half to allow more room for the feed to come out, but we also shortened our flywheel radius so that it would provide enough force to successfully push the material through the pipe and into the briquettes. So another limitation is that the material feed chamber currently requires manual insertion of the material into the pipe because we do not have any sort of automatic fan or feed insertion apparatus into our pipe. So that would be one of the improvements that we would need to make. Additionally, we would need a metal frame rather than wood, because during operation the frame would bend, and a lot of bearing stress would be applied on the holes that we have drilled. So the bearings here would tend to get out of alignment, which caused a lot of problems for the stress acting on the motor. And then the frame would bend, which would not transfer the force into the material and allow the briquettes to be pushed out.
I'm Kai. So with our overall subsystem, our goal for this was to take sawdust or any sort of biomass and compress it into usable briquettes. With a combination of everything in our subsystem, we were able to slowly push out briquettes that are compact and strong. We were able to achieve a slow burn, so that can be used as a viable fire starter. And as you can see in just a little bit, you see a sped up version of our system producing briquettes.